Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions, the mystery of the Pioneer Anomaly, the force that defied physics for 30 years. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 1972, NASA launched Pioneer 10 beyond the asteroid belt, the first spacecraft designed to survive the outer solar system. 8 years later, scientists analyzing its trajectory noticed something wrong. The spacecraft was not quite where Newton's laws said it should be. It had slowed slightly more than gravity could explain, pulled toward the sun by an extra acceleration of roughly 74 times 10 meters per second squared, 10 billion times weaker than Earth's surface gravity, but real, consistent, and utterly unexplained. Pioneer 11 showed the same effect. Independent research groups confirmed it through the 1990s and 2000s using different analysis methods. For 30 years, the Pioneer Anomaly resisted every explanation. Teams proposed dark matter halos inside the solar system. They proposed modifications to Newton's inverse square law at low accelerations. They proposed fifth forces and new physics and quantum corrections to gravity. 2 spacecraft launched in the early 1970s, now billions of kilometers from Earth and completely silent, were hinting that everything we thought we knew about gravity might be incomplete. In 2012, a team at the Jet Propulsion Laboratory published the answer. It was not dark matter. It was not new physics. It was heat. But if the solution was that ordinary, why did it take 30 years and a team of physicists to find it? This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades, and patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding the Pioneer Anomaly. The force that defied physics for 30 years is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Pioneer 10 was launched on March 2, 1972, the first spacecraft designed to travel beyond the asteroid belt and survive the outer solar system. It carried a gold-anodized aluminum plaque depicting a man and woman and a diagram of our solar system, a message to any civilization that might intercept it. It was powered by radioisotope thermoelectric generators, or RTG, which convert heat from radioactive decay into electricity to run the spacecraft's instruments. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered Pioneer 11 launched April 5, 1973 on a similar trajectory. Both spacecraft used Jupiter's gravity for a slingshot maneuver. Pioneer 11 then visited Saturn before heading into interstellar space. Both are now beyond the heliopause, the boundary where solar wind gives way to the interstellar medium. Pioneer 10 last received signal was January 22, 2003. At a distance of approximately 12 billion kilometers, Pioneer 11 fell silent September 30, 1995. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. By the late 1980s and early 1990s, analysis of Doppler tracking data from both spacecraft revealed a problem. Both were decelerating slightly more than gravity alone could explain. The anomalous acceleration directed toward the Sun was approximately 8.74 times 10 meters per second squared, tiny by any ordinary standard, but persistent, consistent across both spacecraft, and impossible to explain using known physics. It became known as the Pioneer Anomaly. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation, but the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the Pioneer Anomaly was confirmed by multiple independent research groups throughout the 1990s and 2000s using different analysis methods. It was not a data artifact or a calculation error. The anomaly appeared in both spacecraft at roughly the same magnitude, though slightly stronger in Pioneer 10 than in Pioneer 11. By 2002, a comprehensive analysis by John Anderson and colleagues at JPL had established it as a genuine and unresolved physical puzzle. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of proposed explanations for the Pioneer Anomaly included some of the most radical ideas in contemporary physics. Researchers proposed dark matter distributed within the solar system, creating an anomalous gravitational pull. Others proposed modified Newtonian dynamics, an alternative to dark matter developed by Mordechai Milgrom in 1983. Still others proposed entirely new fifth forces of nature or corrections to general relativity operating at very low accelerations. None fully worked. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. In 2012, Slava Tarashev and colleagues at JPL published a comprehensive resolution in Physical Review Letters. They recovered and digitized 30 years of previously unanalyzed Pioneer telemetry, including temperature records from the spacecraft themselves. Thermal modeling showed that anisotropic heat radiation from the RTGs, heat escaping asymmetrically from the spacecraft's rear, generated a tiny but consistent recoil force directed toward the Sun, exactly matching the observed anomaly. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Pioneer Anomaly, the force that defied physics for 30 years. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that thermal radiation pressure from the spacecraft's own radioisotope thermoelectric generators accounts for the Pioneer Anomaly. Heat escaping asymmetrically generates a tiny recoil force directed sunward. Slava Tarashev et al., JPL 2012, the accepted solution. The main objection at the time was that thermal modeling of spacecraft decades after launch seemed speculative. The 2012 paper overcame this by recovering original temperature telemetry, making the thermal solution definitive and closing the case. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that modified Newtonian dynamics, MND, developed by Mordechai Milgrom in 1983, proposes that Newton's second law breaks down at very low accelerations, the regime Pioneer operated in. The Pioneer Anomaly was cited as potential evidence for MND. The main objection: the 2012 thermal explanation fully accounts for the anomaly without invoking MND, and the anomaly magnitude does not align with specific MND predictions in the solar system's weak field regime. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that dark matter distributed within the solar system, forming an inner halo creating additional gravitational drag on outbound spacecraft, was proposed by multiple researchers, alongside proposals for a new fifth force of nature. The main objection: solar system dark matter dense enough to produce this effect would cause measurable perturbations in planetary orbits. No such perturbations are observed, and the 2012 thermal solution made all such proposals unnecessary. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Pioneer Anomaly, the force that defied physics for 30 years, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes Tarashev et al., 2012, Physical Review Letters. The team spent years recovering Pioneer telemetry from archived tapes, including previously unanalyzed temperature sensor readings from both spacecraft. Building a detailed thermal model accounting for RTG configuration, spacecraft geometry, and heat emission patterns, they showed anisotropic thermal radiation fully accounted for the Pioneer Anomaly. The result was confirmed by independent groups. No new physics was required. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the anomaly was slightly stronger in Pioneer 10 than in Pioneer 11, a detail that seemed puzzling until the thermal model explained it. The two spacecraft had different RTG configurations and different heliocentric distances during measurement, producing marginally different thermal recoil magnitudes. This asymmetry became confirmation of the thermal model rather than an objection to it, since the model correctly predicted the relative difference between both spacecraft. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the Pioneer Anomaly resolution demonstrated that even well-understood spacecraft produce subtle unmodeled forces. Thermal recoil is now factored into trajectory planning for all deep space missions, including New Horizons, launched 2006, and now beyond Pluto. No subsequent deep space mission has exhibited an unexplained trajectory anomaly of this kind. The episode established thermal emission asymmetry as a known systematic effect in precision spacecraft navigation, now routinely measured and compensated for in mission design. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Pioneer Anomaly, the force that defied physics for 30 years. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Pioneer Anomaly is a closed chapter in physics. The 2012 Turyshev solution is accepted consensus, but the episode left a lasting mark on how space scientists approach precision navigation. For 30 years, a tiny discrepancy in two aging spacecraft tempted physicists with the possibility of physics beyond general relativity. The answer turned out to be mundane: heat from the spacecraft's own generators. The case illustrates a recurring pattern in precision measurement. Anomalies that persist for decades rarely require new laws of physics. They usually require better accounting. Pioneer 10 and 11 continue traveling outward in complete silence. Now well beyond the solar system, they will not encounter another star for millions of years. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis. And the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Pioneer Anomaly, the force that defied physics for 30 years, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Pioneer Anomaly ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.